All right, so we're doing Chapter 8, Section 5, adding and subtracting rational expressions. So rational expressions are ones that have a polynomial on the top and a polynomial on the bottom. When we're adding or subtracting these kind of fractional polynomials, we're going to have to find a common denominator. In order to find the common denominator, we're going to need to find the least common multiple. So the first thing I want to do is go over finding the least common multiple, because it's been a while since we've had to do this. So if I say I had a denominator that was 12x squared y times x squared plus 2x plus 1 and 18x y cubed times x squared plus 5x plus 4. These are the steps for finding the least common multiple. The first thing you do is find the prime factors of each expression. So 12 is 4 times 3, or 2 times 2 times 3. X squared is, x squared. Y to the 1 is y to the 1. X squared plus 2x plus 1 factors to be x plus 1 squared. 18 is 9 times 2, or 2 times 3 squared. So now we're getting down to its nitty prime factors. It's got an x that just comes right on over. It's got a y cubed that comes right on over. And x squared plus 5x plus 4 factors to x plus 1 and x plus 4. So first step, get everything down to its prime factors. Factor the heck out of everything at each term. Now, step 2, write the product of the prime factors, each raised to the greatest power that occurs in either expression. So here I have, write the product of the prime factors, each raised to the greatest power that occurs. So now I've got, if I look 2 squared and 2, I need to take the highest power that it occurs. So 2 squared is the highest power that 2 occurs. 3, I have a 3 on the top of it, and then 3 squared for the second one, 3 squared, so you're taking the highest one. I have an x and an x squared, so I take the x squared. I have a y and a y cubed, I take the y cubed. I have an x plus 1 squared and an x plus 1, I take the squared. And I have an x plus 4. Then you go ahead and multiply all that together, and you get the least common multiple. So taking out all the repeater stuff is 36x squared y cubed, x plus 1 squared, x plus 4. This is the most difficult example of least common multiple that you'll ever see in your life, which is why I printed it out. Very good. So convert it into primes and then take the highest degree of that prime factor. All right, so let's practice that. A says, what's the least common multiple of 2x plus 4 and x squared minus x minus 6? So the first thing that we're going to do is we're going to factor each of these items. So 2x plus 4 factors to 2x plus 2, and x squared minus 6 factors to x minus 3x plus 2. One thing to watch for is when you're factoring, the first one gives you a clue as to how to factor the second one. They're sometimes you'll factor in that they won't have any factors in common, but most of the time, one will lead to the other. So use your detective skills. Be okay to go, oh, x plus 2 is a factor. It's probably going to be a factor to the next one as well. Okay, so we have, to find the LCM, least common multiple, we take each prime factor. So I have 2, it's only to the 1 power. I only have one of them. I have x plus 2. I have it here and here, but each case, it's only power 1, and I have x minus 3, only to the power 1. All right, so next problem. So we take a look at problem B. X squared plus 3x minus 4 factors to x plus 4, x minus 1. X squared plus 2x minus 8 factors to x minus 2, x plus 4. And x squared minus 4x plus 1 factors to x minus 2 times x minus 2. So what we're going to do is we're going to write each factor once. Even if it repeats itself in the next one over, we're only going to write each factor down once. So x plus 4, I'm going to write that down here. So the LCM is x plus 4. I only write it down once, so I'm going to go ahead and cross it out because I've written it down. X minus 1 occurs, and I'm going to cross that out so I can remember, oh yeah, I've already written that down. And then this is x minus 2, and in fact we can save ourselves some writing because it happens twice. So we're going to go ahead and write a squared. Because here it's going to end up as x minus 2. Highest power stays is. So the LCM is x plus 4 times x minus 1 times x minus 2 squared. So the least common multiple of the denominators of two rational expressions is called the least common denominator. You can use the least common denominator to add or subtract the expressions. So this is how it rolls in a fraction. When I have 1/8 plus 1/10, that's 1 over 2 cubed plus 1 over 2 times 5. So we say, what is each one missing? This guy is missing a 5th power. This guy is missing a 2 to the 2nd power. So we go ahead and say 2 to the 3rd times 5 is our least common denominator. Because we take the highest power of each factor. And then so you say, then I'm going to put whatever that fraction is missing onto my previous fraction. So 2 to the 3rd is missing this 5th factor. So we're going to go 5 over 5 because we can't just multiply the bottom by 5. That would not equal 1. We got to keep the terms the same. So we get 1 over 2 cubed times 5 over 5. That gives us 5 over 40. And this guy needs a 2 squared because it's already got a 2. It just needs 2 more. So we go, that is 2 to the 4th, which is 4 over 40. So now that we have a common denominator, you can add the tops together, and the denominator stays the same. So 5 plus 4 is 9, and the result is 9 over 40. We're going to go ahead and do that with problems that are rational expressions. So what is the sum of the two rational expressions in simplest form? State any restrictions on the variable. So the first thing we got to do is we got to factor. And you look at this guy here. X minus 1 is already factored down. So he is definitely, so let's go least common denominator. I'm just going to put it together up here. X minus 1 is definitely a part of our least common denominator. So we go x plus 1, x minus 1. So I'm rewriting that. I'm going to keep some space for the least common denominator fraction that it's going to be multiplied by. And then I'm going to go ahead and factor this denominator here. X squared minus x factors to be x times x minus 1. So x is a factor. I already have x minus 1, so I just don't have to write that. Power 1, here it's power 1. So my least common denominator is x minus 1 times x. I already have the x minus 1 here. So I need to give it an x on the top and an x on the bottom. This one already has the x times x minus 1. We're done. We don't have to add, we don't have to multiply by anything to get this to be the right denominator. Okay, so now I need this x to be multiplied through. So the new numerator for the first one is going to be x squared plus x. And it's going to be plus negative 2 all over x times x minus 1. So once you have your common denominator, you can write it all, you can go ahead and write it as the denominator, and then add, or if this is subtraction, subtract all of your terms on the top. All right, so we are going to do the same process with b. So we're going to go ahead and this is the difference of squares, which is x minus 2, x plus 2. And the other one already has just one factor, x plus 2. So we're going to go ahead and write the least common denominator. It is x minus 2. That's here and here. And x plus 2. So we're going to give, this guy already has both of them, so we can just rewrite it as x over x minus 2, x plus 2. And then we're going to give this guy an x minus 2, because he doesn't have one. He needs equal communism. We're just redistributing our wealth. Which poor people really love, but the rich not so much. They put themselves up as dictators, and then they just take the big. Okay, so then we write it as one denominator, x plus 2, x minus 2. And then we put it x plus x minus 2. We go ahead and combine these like terms, and x plus one more x gives us 2 x's. And I know it looks a little bit like a y, so remember we're just x's here. And just for fun, we'll factor the top. Don't forget about the part where it says name any restrictions on the variables. So if we look at our first problem, which was here, we can't have x cannot equal 0 and it cannot equal 1, because that will make the denominator 0. Same here, x cannot equal positive or negative 2. Go ahead and take a moment. Subtraction is super close to addition, so it's minusing. The only tricky part is making sure you minus what's behind the minus sign. So go ahead, if you're watching at home, pause the video, find the LCD for x minus 2 and x squared minus 3x plus 2. All right, to find the LCD, we need to factor this guy right here. So x squared minus 3x plus 2, I'm going to use the x minus 2 as a little detective clue to see what my factoring is going to be. And the first thing I want to think of, does x squared minus 3x plus 2, is x minus 2 a factor? So we go, what two numbers multiply to give you positive 2 and add to give you negative 3? Well, negative 2 and negative 1 fit that description. So my denominator here is x minus 2 and x minus 1. So now I'm going to start from left to right, and I'm going to list all my factors. So x minus 2 is a factor. X minus 2. Oh, I already have that, so I don't have to rewrite it. Once I've written the factor once, I don't have to rewrite it. I've already written x minus 2. Now I write x minus 1. So my least common denominator is x minus 2, x minus 1. This guy, the one on the left, already has x minus 2, x minus 1. He doesn't change. We don't have to multiply him by anything on the top or bottom. This guy right here, he only has an x minus 2, so I need to go ahead and give him an x minus 1. So I'm going to get x minus 1 times x plus 3 minus 6x minus 7. Now I have some cleaning up to do. I'm going to go ahead and multiply x minus 1 and x plus 3. And that's going to be x squared minus 1x plus 3 plus 2x minus 3. And then I'm going to distribute out the negative. Minus 6x plus 7 all over x minus 2, x minus 1. Now I'm going to combine like terms. So I get x squared, 2x minus 6x is negative 4x, and negative 3 plus 7 is plus 4. It does want it in simplest form, so we're going to go ahead and multiply out. I'm going to look first, can I factor this guy? X squared minus 4x plus 4. Negative 2 times negative 2 is positive 4, and negative 2 plus negative 2 is negative 4. All right, so before I cancel out and get simplest form, I'm going to go ahead and restrict my variable. X cannot equal 2 or 1. If it equals 2 or 1, my denominator is going to be 0. So now that we have that, let's go ahead and cancel out one of our x minus 2's from the top and bottom. So even though it cancels, we still have to restrict the domain. We still can't equal x. X still cannot equal 2. It's your restriction on the domain needs to be before you simplify. All right, now it's going to get crazy up in here. We are going to do complex fractions. Yay! So if you thought the fractions before were complicated, we are now rolling into complex fraction land. It's a rational expression that has at least one fraction, its numerator or denominator, or both. Here's some crazy examples of complex fractions. Super complicated looking, mega easy if you just remember how to tackle these guys. So sometimes you can simplify a complex fraction by multiplying the numerator and the denominator by the least common denominator of all rational expressions. You can also simplify them by combining the fractions in the numerator and those in the denominator. Then multiply the new numerator. So this is kind of the important part. To get rid, when you divide by a fraction, it's the same as multiplying by the reciprocal. So if we can get it back into multiplication, it will be less arduous a task. All right, so let me show you how that looks. So before I can multiply by the reciprocal, I need a common denominator for 1 over x plus 1 over y. I know these are already factored out, so I know my common denominator is going to be x and y. So I'm going to need, from this guy, I'm going to need a y over y, and for this guy, I'm going to need an x over x, so that can have the common denominator x over y. So 1 times y is y, and 1 times x is x. So the denominator is x, y plus x over xy. I go ahead and write its original, and then I remember. Dividing by a fraction is the same as multiplying by the reciprocal. I'm going to go ahead and write x times the reciprocal. So instead of xy being on the bottom, xy is on the top. Instead of x plus y being on the top, it is now on the bottom. Otherwise, I switched to x and y because I like things alphabetically. So this becomes x squared y over x plus y. And this is so much better than this crazy original one that we have. Okay, so we're going to do the same thing except for both the numerator and the denominator, we're going to find a common denominator and combine our two terms on the top and the bottom. So I look here, I have an x and an x plus 1. So my common denominator is going to be x times x plus 1. So this guy needs an x plus 1 over x plus 1. And this guy needs an x over x. I'm going to go ahead and FOIL x plus y times x minus 2 is x squared. 1 plus negative 2 is negative 1. And 1 times negative 2 is negative 2. And this one is a plus. So we're going to say plus 2 times x is 2x. Then we're going to go ahead and combine our like terms. We got x squared. We got negative x plus 2x is 1x minus 2. And then this guy, my denominator here, this one has x minus 1 and an x plus 1. So to have a common denominator of x minus 1, each of these factors, x plus 1, I'm going to need an x plus 1 on the top and on the bottom, on the left-hand side. And I'm going to need a x minus 1 and an x minus 1 on the top and the bottom. So my new one becomes, I'm going to multiply 3 to each of these guys, so it's 3x plus 3. And then I have a minus sign here. So I'm going to go minus 3, parenthesis, because anything that I multiply out is going to be minus. X times 1 is x, and negative 1 times 1 is negative 1. Well, okay. So let's write what that equals. 3x minus 1x is 2x's. 3 minus negative 1 is the same as 3 plus 1, which is 4. And then I have my common denominator. Okay, so my new guy is this. Whew! Okay, so I'm going to take, I'm going to go ahead and write it, and then, because dividing by a fraction is the same as multiplying by the reciprocal. And as we're writing this, I want you to think of how would I factor x squared minus, or sorry, x squared plus x minus 2. So that would be times the reciprocal, so it would be x minus 1, x plus 1, 2. Go ahead and cheat and factor that out. 2 and x plus 2. How does this guy factor here? What two numbers multiply to give me -2 and add to give me 1?
Negative, wait. Add to give you -2, -1, -1.
Add to give you 1, multiply to give you -2.
Oh, -1, negative. Use there. Ooh, how do I go sleep?
X plus 1, 2, x plus 2. Okay, let's restrict our domain. So before we start canceling stuff out, we're going to say x can't equal 0, -1, or -2. Now we're going to cancel the heck out of this shenanigans. X plus 2 and x plus 2. X plus 1 and x plus 1. My new denominator is 2x. My new numerator is x minus 1 squared. Which is way more pleasing than what we had to begin with. Alright. Word problem. I really thought it was important to include the miles per gallon word problem because it's just looking at it, you can't kind of noodle your way through, especially with the rational exponents and stuff. So I wanted to show you an example of how that works. So a woman drives an SUV and gets 10 miles per gallon. Her husband drives a hybrid that gets 60 miles per gallon. Every week they travel the same number of miles. They want to improve their combined miles per gallon. They have two options on how they can improve it. They can tune up the SUV and increase its mileage by 1 mile per gallon and keep the hybrid as it is. So, and that's true. That's how the better maintenance, tire pressure, oil change, the better you care for your car, the better gas mileage it gets. They can buy a new hybrid that gets 80 miles to the gallon, and keep the SUV. So they can buy a new hybrid to get better miles per gallon.
What's the
old hybrid that they had gets 60 miles per gallon. Which they just want to know straight up which option will give them the better combined miles per gallon. So they're in it for the long run. So the combined gas mileage is total miles divided by total gallons. So we're going to start with the equation. Combined miles for the gallons is the SUV miles plus the hybrid miles divided by SUV gallons plus the hybrid gallons.
We can't move the thing.
Nope. All right, so we're going to define our variables. We're going to let x equal the number of miles each person drives in a week, and they drive the same number of miles a week. We're going to take a look at option 1. We got the tuned SUV gets 11 miles per gallon because it's 1 better than the 10. So it's now 11. The hybrid gets 60 miles per gallon. I'll keep option 2. We'll do option 1 first. The gallons used by each vehicle are miles divided by miles per gallon. So think about if I have gallons. I just want to get gallons, so I go the number of miles divided by miles per gallon. So the number of miles, he goes X, she goes X, divided by miles per gallon, X over 11 plus X over 11. That's the SUV plus the hybrid miles, 60, sorry. X over 11 plus X over 60. And so now we're going to find the least, common denominator of 11 and 60. And they don't have any common factors, so you just got to straight up multiply 11 times 60, which is 660. But x plus x does equal 2x. So we get 660 times 2x over 660 times both of our terms here. And we get 1,320x divided by 60x plus 11x. 60x plus 11x is 1320x over 71x. So option 2, SUV is still 10 miles per gallon. The hybrid is 80. What's the common denominator between 10 and 80? So 10 is 2 times 5, and 80 is 4 times 20, so it's 8, which is 2 to the 3rd, times 10, so it's 2 to the 4th, times 5. So I need to give this guy, so I need to give him 3, so to equal, yeah, so the least common denominator is 80, so I multiply the top and the bottom by 80 over 80, and we get 2x times 80 over x over 10 times 80 plus x over 80 times 10, or 160x over 8x plus x. That gives us 160x over 9x. X divided by x cancels. And we get about 17.8 miles per the gallon. So option 1 gives the better combined miles per gallon. Go ahead and write your summary. Make sure you include the learning objective. Make sure to include how to find the least common denominator and some steps for when we have complex fractions.
I'm gonna put, I don't understand why.